Hi, James here with Trident Custom Design. Today I'm talking about memory foam, specifically in motorcycle seats. What has to be understood about motorcycle seats is the seat itself is your interface of your butt to the bike. And the transfer of energy is very important with what we're trying to incorporate, or actually what we're trying to reduce is the transfer of energy. Every time your bike hits a pothole, hits a speed bump, or anything else on the road that's going to cause a jolt that's going to be transferred from the motorcycle frame into your butt and ultimately into your spine. Now, the first criteria of a motorcycle as far as comfort goes when riding is your riding posture. And that's going to be determined by your foot peg distance fore and aft, up and down in relation to the seat, and also your handlebar position, your grip position in relation to the seat, because that's going to determine your riding posture. Now, if you have an upright position in your vertebrae, your discs are going to transfer energy up through the spine more evenly, versus if you're bent over, then you're going to have a compression of the disc between the vertebrae on the forward side of the spine, and then the energy is going to be transferred unevenly through the spine, and that's going to cause fatigue over a period of time. So with the motorcycle seat, a gimmick that is often touted is 100% memory foam seat. Well, there's a problem with that. Memory foam is not designed to absorb energy. Memory foam is designed to spread the energy deposited over a broader area. It conforms with the irregularities with whatever is pressing against the foam more evenly, and so it spreads the load out more evenly, so it's not a pinpoint load that's felt like on your tailbone or on your butt bone and your pelvic bone, that kind of thing. You can see this if we take this sledgehammer. Well, first let me say I just did a seat that was built in 2021. And I think they said they paid $800 for this custom seat to be built. So the seat was 100% memory foam. Everything in it was memory foam. This is the plug that I cut out of the seat in order to make it more comfortable for the customer. So you can see that the date on the plug and whoever signed that is who built the seat was February of 2021. The problem is they constructed the seat 100% of memory foam, top to bottom. So this is the plug that I pulled out and replaced with a properly laminated foam build based on the rider's weight and body style. So if we take this memory foam and we hit it with a hammer, you can see that there's no transfer or no absorption of energy. The energy is transferred 100% into the workbench and doesn't cause the hammer to rebound at all, because all the energy is gone. It's been deposited into the bench, which would be your seat if this were the bike and the bench is your butt. Versus if we take, for instance, a 50 density foam, and now we hit that 50 density foam with the hammer, you can see that the hammer rebounds because the energy was not 100% deposited into the bench. It is absorbed by the foam and then sent back into the hammer to lift it back up, which means it's going to redeposit that foam or that energy into the bike itself and not up through your spine. This is very similar to what you see with the Newton cradle, where you have a very solid medium, and when one ball comes down, it hits the stack of balls, and that energy is deposited and transferred through the balls into the last ball, and the last ball being a representative of your body or your butt on the seat. So you've got this versus this. No rebound, no energy absorption, 100% deposited into your spine. So the way to properly build a seat is, first of all, you have to take in rider weight and body style. So if you're having a custom seat built and your seat fabricator didn't ask you how much you weigh, you're going to get a generic built seat based on their best guess. I use a protocol that you have different densities of foam. So you have a 50 density, a 30 density, 35, and a 65. And we go all the way up to a 95 density that's back there on the bench. Rarely used on a motorcycle seat unless it's somebody that's weighing upwards of 250 pounds. So the protocol for me is, starting off, if somebody is 100 pounds or less, I'm going to use a 35 density foam. If we take this cylinder, and this would be representative of your tailbone, and we set this down here, and then we take our hammer and we set that on there, you can see how it conforms around your tailbone, or around this cylinder representative of your tailbone. The memory foam does the same thing. It just does a better job of conforming. So when you put that hammer on there, it's because it's considered more of a liquid than a solid, or more of a liquid than a foam, so it's going to conform better. But again, you can see we got no bounce in this hammer, so the energy is being deposited right into that cylinder, which is representative of your tailbone. So if we take, for instance, a 50 foam and we put that up against your tailbone, we set the hammer on there, we've still got some decent conformation of the foam around the load point, but we've also got energy absorption. You can see how that hammer bounces around and rebounds, because that energy is being put back into the hammer or back into the frame of your motorcycle. Now, as you increase in weight, you know, we have all the way down to a 30 density. So this is going to be for somebody that's 100 pounds or less. And then we've got a 35 density. So this would be somebody that's like maybe 100 to 150 pounds, in that range. And then we've got a 50 density, so 150 to 180, 200 pounds. And then up to as much as a 65 density for somebody who's 200 pounds or more. So much less deformation there with the same weight. So as you increase weight, you're going to get similar deformation, but you're going to get that energy absorption that's going to be deposited back into the frame of the motorcycle and not 100% deposited into your spine. Also, another thing that could be done to enhance the comfort of the seat is to use multiple densities, or to laminate dual or triple densities in the seat foam build itself. So you may start off, depending on the overall weight, of maybe a 65 density as your base layer, and then come in with a, maybe a 50 density of your second layer, and then your top layer that's going to be directly in contact with your rear end, or your butt on the seat, is going to be maybe a 30 density or a 20 density. So as you sit on this, as you progress down, as the weight increases, you have a real soft feel starting out, and then as the weight increases into the seat, it progressively gets firmer the further you get into the seat. And that's just another way to add comfort. So you kind of have a soft feel against your butt when you're first on there, when you're riding. And then as that impact comes up, or as you get deeper into the density, it gets firmer progressively instead of a real hard jolt into your bottom side. And that increases the comfort. The problem is with this takes time. And a lot of places are trying to just get the work out as quickly as possible, and they don't want to take the time to build these multiple layers. You have to pattern each layer, you have to glue it together. If you use the wrong glue, it's not going to perform as well. If you use a neoprene glue, which a lot of places use a Landau top and trim adhesive, that actually puts a very thin layer of neoprene rubber between the foam laminates, and that creates a hard point. So the glue selection is important. You want to use a light tack glue that's going to hold it together until you can get the whole thing built up. And then the cover of the seat helps keep everything in conformity. You don't really need a really strong glue that's going to create a hard barrier between layers and defeat the purpose of the multi-layer densities. So that's a little bit about the difference. Just remember the Newton cradle when it comes to how you want your bike seat to perform, how you want the foam in your bike seat to perform, and understand that memory foam has a purpose, but its purpose is not to reduce the amount of energy that you feel in the spine when you're riding down the road and you hit that speed bump or that pothole. So that's a little bit of our process when we're talking about building motorcycle seats. Check us out at tridentcustomdesign.com. Anywhere in the Tampa Bay area, from Sarasota all the way up to Crystal River. If you've got a boat, an aircraft, or a motorcycle seat that you need properly built or custom designed, give me a call. Thanks. Take care.